Hi, today is inverse trig functions and differentiation. So remember inverse trig functions, we know that because the trig functions, the original, are periodic, they look like they repeat themselves or they look like snakes, okay? Then when we apply the horizontal line test, the function does not pass, so the inverse is not a function. So what we can do instead is restrict the domain. And so that when we take the inverse, we will end up with a function. So we end up with functions like the ones listed here. Okay, so I have the inverse of arcsine, remember, and so we restricted the domain to negative pi over 2 to pi over 2. So first and fourth quadrant, and then the range of the original would be -1 to 1, and then because of the inverse, it's flipped. Okay, so on and so forth. These are what your inverse trig functions look like. And on the tangent function, let's just remember that the limit as x approaches infinity of arctan or tan inverse of x is equal to this horizontal asymptote at pi over 2. And the limit as x approaches negative infinity of arctan of x is equal to negative pi over 2. All right, so this is a little review from pre-calc, but just remember the arcsine of -1/2 would be, so if, I don't know, this is just another way to solve these, but if I have y is equal to the arc sine of -1/2, the official way to change the form to like regular sine would be to take the sine of both sides. So the sine and the arc sine cancel, and that gives me sine y is equal to -1/2. Okay, and then I just remember from trig that a triangle with a -1/2 height or y value, so if that's y, would be the angle y would be negative pi over 6. All right, next up, arc cosine. So we can do the same thing. So let's set this equal to y, and then take the cosine of y and the cosine of arc cosine. Those cancel. We get the cosine of y is equal to 0. So when is cosine 0? Remember, it's when the x value is 0. So that would be the angle pi over 2. So y is equal to pi over 2. All right, arctan. So maybe you don't like taking the tan of both sides. You're just going to say the tangent of y is equal to the square root of 3, and then tangent root. So it has to have a root 3, and it's positive. So we have root 3 over 2, 1/2, oops, 1/2 and 1. So when I divide root 3 over 2 over 1/2, we're just multiplying by 2, cancels to give me root 3. So this angle right here, y would be pi over 3. So y is equal to pi over 3. Remember? Trig. All right. So we have the tangent of the arctan of 2x minus 3. So this is the ratio, and this is the angle, right? So we're solving for what x value would match the pi over 4 ratio, their tangent ratio. So I'm going to say the tangent of pi over 4 is equal to the ratio 2x minus 3. And I know that tangent pi over 4, I can just evaluate that. So I'm just going to draw it on the side. I have pi over 4. That's a 45-degree angle, so that's root 2 over 2. and root 2 over 2. So the tangent would be 1 since the side lengths are the same. Okay, so you get 1 is equal to 2x minus 3. And then I solve for x, adding 3. So 4 is equal to 2x, divide by 2, and I get x is equal to 2. So in order to make, basically, in order to make this ratio equal 1, my x value would have to be 2. Okay, using a calculator. Okay, I'm going to pause the video so I can grab my calculator. Pause, pause, pause. All right, the arc cosecant of 2.590 is equal to y. So remember, there is no arc cosecant button, so we're just going to have to like change the form so it looks nicer. So what I need to do is change this into the cosecant of y is equal to 2.590. Remember, this is your ratio and your angle, since we're talking about the inverse. And then what I'm going to do is change, I'm going to use my trig properties to change the cosecant of y to 1 over the sine of y using the quotient property, or no, the reciprocal property. And then when I do that, I have to reciprocate my angle. So or my ratio, 1 over 2.590. So now what I have is y, okay. Well, I'm going to flip these. So I have y. Oh, wait. No. I messed up. Let's do this again. Okay. So I'm going to write my ratio as 1 over 2.590. So when I do that, that's equal to the sine of y, because that is because the cosecant of y is equal to 1 over sine y, or sine y is equal to 1 over cosecant. So that's the reciprocal. And then what I'm going to do is change my answer so that I have y is equal to, we're going to re-invert it, the arc sine of 1 over 2.590. So the moral of the story is when I plug this into my calculator, I am going to use the arc cosecant, or when I'm evaluating arc cosecant, I am going to use arc sine because they're reciprocals, but I also have to reciprocate the ratio because, reciprocals. Okay, so what I'm going to do is grab my calculator, make sure I'm in radian mode. Cool. All right. And I'm going to change my calculator to math print because I think most of your calculators are math print. So I'm going to do second inverse sine of 1 over 2.590. Boom, bang. I get y is about equal to 3 decimals, 0.396. All right, so I got y is about equal to, wow, 0.396, rounded or truncated, same in this case. All right. Again, trig review. So we're going to use right triangles to solve. So we're going to do the cosine of the arc sine of x. So we need to start on the inside. So what is, if I'm going to draw a little triangle, and since we're talking about arc sine here, my ratio is x, okay? So x over 1. So the y value would be x, and the hypotenuse would be worth 1, okay? Could I solve for my horizontal side of my triangle? Yes, I can. Let's use some Pythagorean theorem. So I got x squared plus a squared is equal to 1. So a squared is going to be 1 minus x squared. And I get a is equal to the square root of 1 minus x squared. So that's that length right there. Okay. And then what I need to do is say, well, what is this angle So if I'm doing the arc sine of the ratio, then I'm just going to label this as like, you know, angle y. Okay. So what is the cosine of y? So when I have the ratio x over 1, I get an angle y. So the cosine of y would be my a over 1 would equal my a value over 1. So the cosine of y is equal to the square root of 1 minus x squared over 1. And we need these to prove some derivatives later. Okay. So in other words, the cosine of the arc sine of x is equal to the square root of 1 minus x squared. Okay, let's do another one. So the tangent of the arcsecant of 5 over 2. So again, this is my ratio, 5 over 2, root 5 over 2. So, and we're talking about secant, or so I put ratio. Okay. All right. So secant is the reciprocal of cosine. So the 5 is the root 5 is my hypotenuse, and the 2 is my x value. Okay. So I'm going to go ahead and write this is and when I have this special triangle here, I end up with some angle that corresponds with those side lengths. So I'm just going to call it y. So now what I'm trying to find is the tangent of y. So tangent would be my y value over, or my vertical value over my horizontal value. So let's go ahead and get my the length of the third side. So 2 squared plus b squared is equal to root 5 squared. So I get b squared is equal to 5 minus 4. So b is equal to 1. Okay, that's sweet. So now I get a tangent value of 1 over 2. Oh, which is equal to, this is all equal to, let's just move you over, the tangent of the arcsecant of root 5 over 2.